Alright guys, here we are today. We are going to talk about solving inequalities. That is our lesson for today, solving inequalities. And the nice thing about solving inequalities is it's going to be back to kind of one-step equations, similar to that, except it's going to be inequalities. And an inequality, that should be writing and graphing. An inequality is going to have a less than sign, greater than sign, less than or equal to, greater than or equal to sign in that, opposed to an equal sign. That is the difference between them. You still need to make sure that you're showing all of your work on all your steps. The difference is going to be you're going to have to graph all of your answers. And that's the key there, is you always graph your answers. So I just have a couple examples to go over today, and then that'll be it. The first I want to talk about, which we did in class a little bit today, was just writing and graphing inequalities. So how do you graph an inequality? How do you write an inequality? So in the first example A, I have a speed limit is 55 miles per hour. Well, what does that mean? Well, speed limit means I cannot drive faster than 55. So the speed that I drive, and I'm going to use D, has to be less than or equal to 55. Less than or equal to 55. So that's how I'm going to write my inequality there. D is less than or equal to 55. Now you can use any variable you want because one was not told to you to use. But that's the variable I decided to use. So I can drive less than or equal to 55. That's my speed limit. Okay. If I had something that was greater than that, I had to have at least that. At least is kind of our key for if it's greater than or equal to. Now I don't just want to write that, I also need to graph the inequality. So to graph it, it's actually going to look like an answer from B. I'm going to make a number line. I'm going to throw some tick marks on there. Just a couple. Got to make sure 55 is on there. That is key. Now that's kind of the number that I'm using in my problem. So I have other numbers on either side. You got to make sure number line is correct. Then I'm going to go ahead and circle the tick mark above 55. So that indicates that 55 is my starting mark, my starting number. Now my next question is, do I want to fill in the circle or do I want to leave it open? In this case, I'm going to have to fill in the circle. The reason that I have to fill it in is because of the equal to part right here, because I can drive 55 miles per hour. I can drive equal to that. So I need to fill that space in. That indicates that I can do that is an acceptable speed. If it's not filled in, that means I would be going too fast. But driving 55 is fine. Now I have to draw my graph, because I can drive not just 55 miles an hour, I can also drive anything less than 55. So to draw anything less, I'm just going to draw an arrow, and I like to make it nice and big so it doesn't look like your number line, and so I can see it. And I'm going to draw an arrow to the left of my answer. And that's going to indicate that my driving speed, I've shaded in my driving speed, that my driving speed can be less than 55 miles per hour. And that's my answer. I'd have to have both parts for my answer there. Now in B, I just have to write, have to graph. It's already graphed for me, so I just have to write the inequality. I don't have to graph it, it's already done. Now I may ask you a question tomorrow, write a real life example where you have to have, that answer. So that's something you got to think about, but for now we don't have to do that. To write this, I just have to look at my graph, and I'm basically going to do the opposite of what I did there. 3 is my indicated number, so I'm going to put my 3. I don't have a variable indicated, so I'm going to do x and then 3. I just used x. You could use any variable. And those are kind of my 2 indicated things. Now, I always like to put the variable first. You don't have to, but I think it's easier if you put the variable first. So put the variable first, put your constant second on the right side. And now I have to figure out my inequality symbol. So my choices are less than, greater than, less than or equal to, greater than or equal to. There's 4 choices. And this one, I've shaded in the numbers that are greater than 3. So I want a greater than symbol. Now I have to decide if it also has the equal to symbol. Well, it's not shaded in. Because it's not shaded in means 3 is not included in the list. So starting at 3, but not including 3, everything greater than that is shaded in. So x is greater than 3. And that's my answer for that. Okay, I'm going to switch slides now. And we're going to go to our next part. Example 2, we're actually going to solve and then graph the inequality. Now again, these are all going to be one-step equations tonight, so that should be pretty simple in solving them. The biggest mistake people make is they put equal signs in between the answers. So please make sure that you have an inequality symbol in your final answer and when you're working through the problem. This is an addition problem, so normally I use my property of equality to solve it. Well, this is going to be my property of inequality. So I'm going to use my subtraction property of inequalities to answer this. And when I subtract, I'm going to get m. Again, it's not equal to. It's going to be m is greater than or equal to 10 minus 5 is 5. m is greater than or equal to 5. Next part I'm going to do is graph it. Now to graph it, guys, I have to use the number from my answer. I'm not using the 10. I'm graphing what m represents. M is greater than or equal to 5. So that's the part that I want to graph. So I'm going to put some tick marks and make sure 5's on it. I'm going to circle 5. I'm going to fill it in because I have the equal to part. And then I want to fill in the numbers greater than 5 because m has to be greater than 5 also. 6 is greater than 5. That's what makes my problem true. So always when you're graphing, you always want to fill in and shade in the sides. That makes your inequality true. Okay, for B, I have x's on the right side this time. So this time I have a minus 12, so I'm going to add 12. That's my addition property of equality. Negative 10 plus 12, they're different signs, so I add them together. That's 2. It's positive because I'm more positive than negative. So 2 is less than x. These actually get tricky, and you can see why I like the variable first. Because these get a little bit more tricky. I'm still going to circle my number 2, but in this case 2 has to be less than all my numbers I shade in. Remember, x represents the numbers you shade in. So 2 has to be less than what is shaded in. If 2 has to be less than what's shaded in, that means I have to shade in everything to the right. And that gets a little tricky because the people see the less than sign, so they want to shade to the left because those numbers are less than. But it's not the variable is less than. This time the number is less than everything that's shaded in. So my number indicates the least value that we have. So you have to be careful of those, and that's why I like to put the variable first. Now if you were to rewrite this, you can't just flip the sides and not change the sign. If you actually would have to, if you move the x to the left side and the 2 to the right side, an equal sign, it doesn't matter. But in this, you would also have to flip the sign. So you could read this as not just 2 is less than x, but you could also read this as x is greater than 2. If I read it backwards, I have to read the sign backwards also. Okay, let's move on. This is our last slide, so if you need to pause it, go ahead. These are my 2 answers here, and here's my last slide. Let's do some multiplying and dividing now. So in 10t is less than 34, so for this one I'm going to divide by 10. That's going to give me t is less than 3.4. How do you graph when you have a decimal? Well, if I want to graph with a decimal, guys, I have to make my graph represent the decimals. So I'm going to do 3, and then I'm going to make that one 3.2, and then 3.4. I did make one mistake here by actually labeling all these. I should have just put the tick marks and let them represent them. I could have just done 3 and 4 and had the tick marks in between, not labeled, and someone should be able to figure out that they each represent 2/10. So I have 3 and 4/10. So I'm going to circle 3 and 4/10. Excuse me. T is less than that. So all my numbers shaded in have to be less than 3 and 4/10. So I'm going to shade to the left. Okay. Now if I wanted to write this another way, I could just write the 3 and then the 4 and then put the 0.2, 0.4, 0.6, 0.8 in there, not label them. That is fine to write it that way. Still circling the 3.4, still shading in. So that's an alternate way of writing it. If you don't want to write in every number, that's okay. You can have the tick marks represent an evenly spaced amount. All right, and for D here, I'm going to use my multiplication property of inequalities. I'm going to multiply both sides by 6. That's going to cross those out, so you get y is greater than 42. So again, solving it is the same thing as the equations. The difference is it's an inequality symbol, so do not forget to put your inequality symbol in there. Got some tick marks. There's no set amount how many you have. You can't just have the one number. You need to have other ones. So you just have some other, and then I want y is greater than 42. I don't have an equal to part in this part, so I'm not going to fill it in. And a shade to the right because I want all the numbers greater than 42 shaded in. And the key on the circle of filling it in is if it's equal to. Not filled in means it's not equal to that. Filled in means it is equal to that. That is our lesson for tonight. Have a wonderful night, and we'll see you guys tomorrow.